Chips. Hey, Aston, how you doing?
Good afternoon, sir. You were saying something?
I was saying good afternoon to you.
Okay, good afternoon, and how are you?
Doing a little better, giving thanks. Um, just waiting for the others to come so we can get going because tonight is a crucial class. So I'll give it about another 9 minutes, another 8 minutes, and start at 10 past. All right. So go and go get a cup of tea and something and relax yourself.
Okay, sir, not a problem. I'll do so.
Cool.
Evening, sir.
How are you, Sham? You all right?
Yes, sir. How about you?
A little better, but I'm giving thanks. Could have been much worse. I'm giving thanks. Uh, Crucial night tonight, starting and finishing a topic. 2 weeks from today is your exam, the 1st of March. And I'm very excited for where we are and for what it is that is to come. So just touch base with the other colleagues now. 7 minutes time and we're starting. I'm starting at 10 past. All right.
Cool, sir.
Mr. Shand, how you doing? Sir, I sent you a message, from last week.
You did?
Huh?
You sent me a message from last week?
Yeah, and you asked me if I did. And you still haven't responded to my message. Or made any changes.
Ma'am, you sure it wasn't done? This is with the editor, don't?
Yeah.
Yeah, man, I'm sure I went
This
and
is
did
the
it.
second time I ask you about Edico. You made adjustment to the first one. Not to the second one.
Strange. I remember reading it and I remember reading it, but I thought I did it. Oh, not reading. That's a problem. Oh, but a bit more. Hold on one minute, please, guys. All right. So thank you for coming out today. AC, I will look at your stuff afterwards. I was trying to log on and look at your stuff for you.
Okay, sir.
Hang on. All right, so I have I have something up. It is applications to differentiation. And I want us to spend some time looking at that today. The truth of the matter is we're starting and we're finishing it off today. We're starting and we're finishing it off today. So um so I'm gonna ask that you give me your undivided. This topic is a topic that comes for full marks. Sometimes it comes for 30 marks. Sometimes it comes for 20 marks. Sometimes it comes for 25 marks. What do I expect? I expect it to come for a full 30-mark question. So if you understand this topic, if you can master this topic, it simply means that you have 30 marks put down in the exam already. It means if you have 30 marks out of 60 for the essay paper, you have 50% of the marks already. You pass the course. Just by doing one question, you pass the course already. And of course, there are other areas that we have covered that I know you guys are understanding. So what I want you to do is focus. Give me your undivided. So it is that we can accomplish together our application to differentiation. So it starts by saying stationary points, SP. Sometimes you hear me speak about SP, stationary points. You'll hear me speak about single variable function. Single variable functions are functions that we're going to be using for calculus 1. When I would have moved to calculus 2, when all of us would move to calculus 2, we're going to be talking about multivariable functions. We're going to be talking about multivariable functions, right? So for now, we're looking at single variable functions. Now, in order to do the single variable functions, one of the things that we're going to be looking at is noting, as we would have done in the past, that we can use f of x or y. Now, if you're using f of x or y, f of x, when we're differentiating, it's going to become f dash of x. And the second derivative will be f double dash of x. And if you're using y, it's going to be dy by dx. And the second derivative will be d squared y by dx squared. You know this. We've done this before. Now, what we need to look at now is how we're going to be doing these questions. But what I have done differently is to give you a summary. Strange. Is to give you a summary of what it is that is going to be required to us. So to determine the stationary point, we're going to differentiate the function f of x. We're going to differentiate the function f of x. And we're going to then set the differential equals to 0. We're differentiating the function first, then we're going to set the differential equals to 0. And then we're going to solve for the unknown. And this will give us the critical values. This will give us the critical values. Then we're going to substitute the critical values into the original function f of x from 1 above. And those results will give me my stationary points, my turning points, or my critical points. So those 3 points are used interchangeably. I can speak about stationary points. I can speak about turning points. I can speak about critical points. I don't know which of the terms CCCJ will use this here, right? But if it says stationary points, if you're accustomed to seeing stationary points and the question says turning points, it means the same thing. If you're accustomed to turning points and the question says critical points, it's the same thing. All right, so just learn that. Stationary points, turning points, critical points, all mean the same thing. All right. Then, to classify the nature of the stationary points, we have 2 methods. First, we're going to use the differential f dash of x, and we're going to differentiate it a second time to find f double dash of x. And then we're going to substitute the critical value or values, or x and y value or values, into the second derivative, f double dash, right here. So if f double dash is greater than 0, then we have a relative minimum. If it is greater than 0, the value is greater than 0, we have a relative minimum. If, on the other hand, the value that we substitute into the second derivative is negative, we're going to have a relative maximum. If somehow when we substitute the values, we get f double dash of x to be equal to 0, then we're going to have a saddle point. Then we're going to have a saddle point. So just remember that. If the value of the second derivative is negative, we're going to have a maximum. If it is positive, we're going to have a minimum. If it is equal to 0, we're going to have a saddle point. There's a second method. I will do that. I'll do that. I don't think I want to, based on time, I don't think I want to teach you the second method. All right, so let me just jump over this. And if there's an example in what I have here that will use the second method. But we'll see what will happen. Now, to determine the point of inflection, we're going to use the second derivative and we're going to set it equals to 0. So we would have found the second derivative from up top. So we're going to set f double dash of x or dy by dx, d squared y by dx squared equals to 0. And we're going to solve for the value of x or values of x. And then we're going to substitute those as my second point into the original f of x function. And those together will give me the points, point or points of inflection. And those occur between 2 turning points. All right. So therefore the question is, well, let me not even answer that part yet. Let me go through and then we'll come back to this. This occurs only for continuous function. We're going to be asking to sketch the graph of the function. That gives you about 6 marks or 5 marks to the question. So the graph sketching is very important. All right, so those are the. So I have a first example here, and I want to work through this example with you. I prefer if you don't write and just look at what it is that I'm doing, and then I'll give you enough time to write so that you can get the fulsome understanding to what is going on here. So it says, given the function y equals x squared minus 6x plus 1. Given the function y equals x squared minus 6x plus 1. We need to evaluate the critical points. Point or points. We don't know what it is. It just says evaluate the critical point or points. All right. So we're evaluating a critical point or points. Now, this is what is going to happen. The first thing we're going to be doing is to differentiate the function. The first thing we're going to do is to differentiate the function. The function is y equals x squared minus 6x plus 1. The first thing we're going to be doing is to differentiate the function. And then when we differentiate the function, we're going to set the derivative equals to 0. So the function is here. When I differentiate x squared, I'm going to get 2x. When I differentiate negative 6x, I'm going to get negative 6. Then I'm going to set the dy by dx equals to 0. So therefore, 2x minus 6 is equal to 0. As the summary said up top, we need to find the value of x. We need to find the value of x. So I'm looking for the value of x, all right? So I'm going to let 2x equal 0. I'm adding 6 to both sides. I'm adding 6 to both sides. So I'm going to get 2x equals 6. When I divide both sides by 2, I'm going to get x equals 3. I'm going to get x equals 3. All right? Now, the information up top says, once I would have found my critical value or values, I now need to substitute it into the original function. The original function is y equal x squared minus 6x plus 1. So I'm going to put x equals 3, the critical value. I'm going to put x equals 3 into the original function. See it here? I'm putting it into the original function. Anywhere in the original function I see x, I'm going to put 3. So this becomes 3 squared minus 6 times 3 plus 1. 3 squares is 9. And 3 times 6 are 18. And plus 1. So I'm going to have negative 8. So that is my y equals negative 8. And my x was 3. So this now gives me my critical point. That now gives me my critical point. All right? So the first thing we do, we differentiate the function. The next thing we do, we set the differential equals to 0. And then we solve for the value or values of x. When we get the value or values of x, we substitute those into the original function. And the pair of those values will give us the critical points. So this question gives just one critical point. All right? And the critical point is going to be 3, negative 8. Now one may ask, what is this critical point? Okay. I did say to you that this is also known as a turning point. Now, I don't know which one of you is the better driver in this class, but picture this. Simon is going to work. Simon drives out. He gets along his avenue and he's driving and he's driving and he's driving up to the top of his avenue. And then remembers that he left his wallet. And today is a day when he didn't pack a lunch. So he has to turn back. But him so upset, say him going to lose 15 minutes out of him journey time, and 15 minutes is very critical because that could mean a half an hour delay with traffic because him coming out of Portmore. And him decides him just go turn the car around without even stopping because him a shutter driver. I'm here to say to you that at some point in time, no matter how good a driver you think you are, that car is going to come to a halt, even a nanosecond. And that is going to be your turning point. And that turning point is you changing direction from where you're going from before, right? So you're changing direction. Now, the change of direction can be of two ways. It can be a maximum change, it can be a minimum change, or it could be a saddle change, which is what it is that we did before. It could be a maximum change of direction, it could be a minimum change of direction, or it could very well be a saddle. All right? So depending on what it is, we will need to find out. And we're going to find out tonight. Then now, we're going to be looking at the coordinates of the y-intercept. Now, hear me out. The y-intercept is when x is equal to 0. The y-intercept is found, is calculated, is determined when x is equal to 0. The x-intercept is found when y equals 0. So technically, the intercept is found, whichever intercept you ask to find, you can put the opposite one to be equal to 0. So I'm saying to you, if they ask you to find the y-intercept, you're going to put x equals 0. If the answer to find the x-intercept, you're going to put y equals 0. You can't answer to find the y-intercept and you put y equals 0. That don't work. It has to be the opposite variable. It has to be the opposite variable. So let me say that one more time for emphasis. If they ask you to find a y-intercept, it means that the x value is going to be equal to 0. The opposite variable is going to be equal to 0. The opposite variable is going to be equal to 0. And if they ask you to find the x-intercept, it means that your y is going to be equal to 0. The opposite variable is going to be equal to 0. So what it is that you do, in this case, they ask me to find the y-intercept, so x is equal to 0. So anywhere in the function, the original function, that is, I see x, I'm going to put 0. So this is going to be 0 squared minus 6 times 0 plus 1. And that is going to be equals to 1. So the coordinate of the y-intercept now is going to be 0, 1. Remember, x is 0. So 0 is written first. Remember, the coordinate here is written x, y. X is written first and then y written thereafter. And then the 1 is going to be written. Oh, goodness. The 1 is going to be written in the y position because y is representing 1 or 1 representing y. And then it says now to determine the critical point, if the critical point is a maximum or a minimum. Now, I did say to you, I'm going to teach you one of the methods. In the interest of time, maybe I'll do the other method sometime later. But in the interest of time, we're going to find a second derivative. Now, we know from up top that the first derivative of the question here is 2x minus 6. 2x minus 6. So therefore, I'm recalling that my dy by dx is 2x minus 6. When I'm trying to find d squared y by dx squared, it means that I'm finding the second derivative. I'm going to differentiate this function once more. Now, when I differentiate 2x minus 6, I'm going to get 2. Tell me if you agree.
I did.
All right. So that's what is going to happen. So I'm going to get 2 for my derivative. Now, I'm investigating the critical point 3, negative 8. Now, this is a constant. The second derivative is a constant. It therefore means that I don't have any of the variable x or y to substitute. So it means that the constant will remain. Now, because that constant is a positive value, it is a minimum. So how do you know that? Let me refresh your memory. I said to you that if the second derivative is greater than 0, like 2, then we have a relative minimum. So because that value is positive 2, you're going to have a relative minimum. Had it been negative 2, you'd have gotten a maximum, a relative maximum. And if when we had done that, it was equal to 0, then we'd have had a saddle point. All right? So we're going to get that minimum. And then they ask us to sketch a graph. To sketch a graph, all the important points that we would, all the important points we would put on the graph. All the important points we put on the, sir, how do we know the important points? The same ones that you just calculated. The turning point, let me show you them. The important points would be the critical value, but the critical point, 3, negative 8. The other one would be the coordinate of the y-intercept, 0, 1, that's 2. And the minimum value, we need to know that at 3, negative 8 is a minimum. The minimum value is turned a particular way. The maximum value is turned a particular way. The saddle point has a particular shape. So let us look at 3, 8. You know what? I'm going to kill 2 birds with 1 stone. That very last chapter on your that very last chapter on your course delivery plan. Talks about software. Let me introduce you to one right about now. Okay, so I don't know why. Are you seeing my screen?
Yes, sir.
Yes.
So it says y is equal to x squared. Y is equal to x squared. I think it was minus 6x down to plus 1. Y is equal to x squared minus 6x plus 1. I think that was it. All right, so look at what is, oh crap, come on, what is wrong with you, Mr. Shand? So look, this is what I want you to do. So we got 3,8. We got 3,8. Sorry about that here. Sometimes I can't reach the mute button when the cough comes on, because the cough comes on so sporadically, so forgive me. 3,-8 is my turning point. Can you agree that that is 3,-8? Can you see that?
Yes, sir.
Yeah, man. And clearly, you can also see that the graph turns upwards. So because this graph here is, because the turning point is actually a, a minimum, remember we did say it was a minimum value? It was a minimum value because d squared y by dx squared work out to be a positive value. So when the second derivative is positive, it is a minimum value. Minimum values turn up. Minimum values turn up. Maximum values turn down. Minimum values turn up. Maximum values turn down. So that's a minimum value. Turns upwards. It turns upwards. Turns upwards. All right. So that's our minimum value. Now we got our, let me go back and show you something here. So we know our minimum value from here. We know this. Oh, the y-intercept is 0, 1. So let me show you where the y-intercept is. The y-intercept is 0, 1. The y-intercept is where the graph cuts the y-axis. The y-intercept is where the graph cuts the y-axis. The y-intercept is where the graph cuts the y-axis. And very important, when you get questions such as these, you're going to be asked to sketch the graph, not to plot, to sketch, right? I cannot tell you how your sketch is going to be, but what I can tell you is that your very important points that you would have calculated, the turning point, the point of inflection, the intercepts, etc., must be represented on the graph paper, on the sketch rather. It's not a graph paper you're going to be getting. You're going to be sketching in your on your answer sheet. So your sketch is going to include all the important points. You can't just draw one U and say, see it there, without putting any values on the graph on your sketch. If you do that, 0. So I would have to see where you drop your Cartesian plane, and you have your x-axis, your y-axis. You're going to have your 0, 1, 2, 3, whatever the situation is, and you're going to sketch the graph. You're going to sketch the graph as neatly and as accurately as you possibly can. Yes, it is a sketch. All right. Now, so when you sketch the graph, and I see all of those values on it, once those values are in place, I have the correct turning point, you get marks. You get plenty marks. I think the sketch is anywhere could be 4 to 6 marks. Easy, right? You don't want to do the other parts of the question and not do the sketch. Not doing the sketch will mean that you can get 25 or 26 out of 30. Right? You want the full 100. All right? So that's what the graph will how the graph will entails. And that's what it will entail, right? No, saw this now. You guys can hear the vibration?
What vibration?
Okay, great. I'm so happy that you can hear the vibration.
We're seeing your WhatsApp though.
Huh?
But we're seeing your WhatsApp though.
Okay, all right. And you're not supposed to be seeing that. But what is happening is I'm outside. I'm actually outside. Hold on. So I'm outside, and them have some outside music go on. All right. So this is what is happening here now. This is what is happening. In this particular question, this is an easy question where you have just we call it just 2 points on the graph paper, because you'll not get a question in the exam with only 2 of those stuff. You'll not get a question with just 2 of those stuff. There's no way they're going to give you a question with just 2 of those stuff. What they're going to give you is a function that is cubic in nature. All right, they're going to give you a function that is cubic in nature. Now, what I want to do is I want to send you this piece of information that I have here, so that you can see what is happening. And so that when I give you one to do for me, you are on the right track in getting the question done up. On the right track in getting the question done up. So allow me to review this before I give it to you. Or better yet, let me get that to you. No, are you understanding what it is that I'm doing so far?
Yes, sir.
All right, good job. All right, so Oh, come on, don't do this to me now. So, all right, so I've just copied that bit of information. There's something else I was going to delete. I was right, I can delete this part. Students, my notes that I share with you is not just for good looks. It is to be used, reminding you that your exam is on the 1st of March. All right, there you go. There you go. So look at that for me, please.
So you're not sharing screen now?
I know, I just sent you something via WhatsApp.
Okay.
Yeah, I had to stop sharing so I can copy some things. Let me know if you see it via WhatsApp yet.
Yes, sir, it reached.
Yes, sir.
All right, nice. So I want you to, all right. So, oh, sorry, I need to reshare this one. I want you to look back at the question and look back at everything that we've done. But let me just explain what it is that I'm asking you to do here in this case. So this is a typical exam question. This is a typical exam question. It says, given that the function y is equals to 2x cubed plus 3x squared minus 12x minus 7, you're going to evaluate the coordinate of the y-intercept. You know how to calculate the coordinate of the y-intercept. Which one we going to put equals to 0?
X.
Very good. You can put x equals 0. Then we can calculate the critical points. To calculate the critical points, what we're going to be doing first is to differentiate the function. And all of what I'm saying to you, you now have it. You're going to differentiate the function. When you differentiate the function, what you're going to be doing is, having differentiated the function, you're going to set the derivative equals to 0. You're going to be solving that equation. And for sure, you're going to end up with a quadratic equation. So you're going to have critical values. When you get your critical values, you substitute those critical values into the original function to get the corresponding value, y value, so you can end up with your critical points. When you get your critical points, you have to determine the nature. So sometimes they say determine if the critical point is our maximum or minimum. Sometimes the question say determine the nature of the critical point. Same difference. So determine the nature of the critical points. What you're going to be doing is finding the second derivative, dy by dx squared, d squared y by dx squared. You're going to substitute the critical value inside the x value of the critical value inside of each. If it is positive, it's a minimum. If it is negative, it's a maximum. If it is equal to 0, it's a saddle point. Then we're going to determine the point of inflection. How to determine the point of inflection? Put d squared y by dx squared equals 0. You solve for the value or values of x there. So when you get that value or those values, you're going to again substitute it into the original function. That will therefore give you your point of inflection. And then to sketch the graph, everything that we've calculated just now would have been indicated on your sketch. All right. So I'm going to give you an opportunity to read through the document again. I've done this question already, so I have the solutions. But what I want you to do for me is I want you to give an attempt of this question for me. It's not difficult. Today is your serious mode. I want all of you to put pen to paper. I don't want to hear nobody tell me say, sir, I like the topic, I don't understand the topic, I have to learn it. Come for the 4th of March, Monday the 4th of March, God's willing. All of you here in class now will be here again when we're having our calculus 2. We don't want no foolishness from nobody. I am not well all of this week, but I'm making a point of my duty. On the mark, get set, go. Start, please. I just remember, I just realized, guys, that I stopped sharing. So do me a favor, just use the diagram that I sent you, the document I sent you just now, all right? How we stay? I don't hear nobody say nothing, saying anything. How we stay? Hmm.
Still working, sir.
All right, good job. Sham, how you stay? Are you okay? You following what does that mean?
Yes, sir, I'm following.
Okay, good job. AC, how you stay? Okay, Mario, how are you?
Coming around, sir.
Good job, my love. Mario? Adrian, how are you? Okay, Tristan, how are you? Are you giving an attempt to the question or are you at work?
No, I'm heading home.
Oh, okay.
We have the
Um,
screenshots there. We have the
okay,
screenshots and I'm going to
okay. Tristan, how are you?
Sir, we just reaching, so I got start. We just text and ask in the group which one for them.
Oh, the one that is in the WhatsApp group. Example 2 is what you're supposed to do.
Yes, sir.
Recording in progress.
No man, no too solid, no man. How many stay? What part of the question are we at? Mhm.
The third point, minimum and maximum.
All right.
Same place me reach, sir.
All right, cool. All right then. Always say. Finish the third part now.
Yes, sir. Doing part 4 now.
I think I made a mistake in part 3, so I'm trying to figure it out.
Okay. Mm.
So we're supposed to sketch a graph as well?
Yeah, man, do the full house, man. Full house. I can see, I can work through with you guys. I can tell me, I can see exactly, wow. Right. Okay. So how far you guys get at it? How far the rest of you reach though? Everybody's at the point where they're sketching the graph?
Yes, sir.
Yes,
I'm gonna
sir.
try sketch graph.
All right, cool. All right, ready or not, here I come. Ready or not, here I come. How far are we now? Everybody give a sketch of the graph. If you don't understand today's sketch, is not a problem. Now, says a yes or no answer. Talk to me.
Figure me I try to figure out how to sketch it, sir.
Don't worry about it. Leave it alone. Let us go through the other part of the question. Remember, it's the first time you're seeing this topic, so if you don't know how to do the stuff, that's fine. Question. How does my question? Oh, my head hurts. Y is equal to 2x cubed plus 3x squared minus 12x minus 7. We're to evaluate the y-intercept. What's the y-intercept?
Sir, I'm get 0 and -7. I don't know if that's right.
0 and -7. Tristan, that was you?
Yes, sir.
I don't know if you're right. Astoniel, is he correct? She's not answering. Simon, is Tristan correct?
Yes, sir.
Okay, Shamari, is he correct? Do you agree with them?
Yes, sir, I agree.
Okay, good. So what needs to happen is we are substituting, it says the y-intercept. Once we're calculating the y-intercept, it means that the other variable is going to be equal to 0. So anywhere in the function y, we see x, we're putting x to be equal to 0. So yes, y is going to be equal to -7. So what's the coordinate then? Because the question asks for the coordinate. The coordinate is what?
0, -7.
0, -7 is correct. Very good, Simon. And the rest of you, I want you to get that. It's 0, -7. Don't just put no -7. Put in no -7, not going to give you the full marks. It says coordinate. A coordinate is your x and y value. Is your x and y value. All right. Am I sharing with you? No? Yes or no?
No,
No.
sir.
No, sir.
Okay. All right. And then now, when you differentiated the function, what did you get?
Six x squared plus 6x minus 12.
Okay. Everybody agree with that?
Sir.
Okay. All right. All right. All right. I'm trying to find the. All right. So the coordinates of the y-intercept. The critical point. What was the critical point? I know I'm going to get some of you right there saying no. Matter of fact, all right. Let me not even go there because let's jump into the end of the story. When Shamari, tell me the differential again, please. dy by dx equals to what?
6x squared plus 6x minus 12.
Tristan, Simon, Astonil, do you agree with that?
I agree, sir.
Mario,
Yes, sir.
okay. Mario, Simon,
Yes, sir.
Adrian, Mario, I'm waiting on you. Let me see if you're here in the first place.
Yes, sir. I said I agree, sir.
Okay. All right, yes. So when I cough, my head hurts and my head is pounding and this cough is just there. Jesus. All right. All right. So you'll get some marks for that. But remember now, for critical points, dy by dx is equal to 0.
Why
you
are
now
you
have to
sharing, sir?
no, I'm not sharing yet
Okay.
because I want to get something from you guys first. So dy by dx is equal to 0. So you have 6x squared plus 6x minus will be equal 0. When you factorize that, what did you get? Anybody?
X squared plus x minus 2.
And what's the final answer?
Or equals 0, so x have two values. X
Yeah, and
minus 2 and x equal 1. You heard what I said, sir?
I did, but it's incomplete.
Is it you want the critical points?
There you go. I do want the critical points.
Minus 2 and 20. And 1 and minus 7.
Anybody disagrees with Aston here?
I got minus 2 and 13 and 1 and minus 14.
Very good, Shaman. Mari, excellent. Now, this is where I'm gonna get off at you guys now. I'm really going to get off at you guys now because this topic is a must-have on the exam paper. And in order for you guys to pass this course, to move on to the second leg of the course, we're gonna have to go do it. You're so patient I was with you just now by giving you the question and ask you and send off the steps for you so that you can go ahead and look at it and take your time and do the question. It is because of this very reason. I'm not doing any foolishness with any of you in the class. We're not gonna learn this something. So if I get off at you, it is for your own good. No, I will share because I knew that the factorization of that trinomial was going to give some problems. That's why I wasn't sharing it. I knew that the factorization of the trinomial was going to be problematic. And it shouldn't have been problematic because we've got to this point already when we're looking at continuity. That was topic number 2. This is topic number 5. We shouldn't have a problem. Say that again. So we shouldn't have a problem with this at this stage of the game when we would have gone through factorization long before. And let me tell you, matter of fact, I lied. It's not even topic 2. It is topic 1. Because when I gave you limits of the function and the indeterminate form, and there was something in the limit that was preventing the true limit from coming out, you had to factorize and cancel out true or false.
True.
Yeah. So we did this from the start of the semester, and now we have 2 weeks for the semester to end, and people are still struggling at this point. That's why I wasn't sharing. People cannot be struggling at this point. It's the same thing that we're meeting up again with the factorization. Come on now. Your exam is on March 1. God's willing, 2 weeks time from now, I am locked off drinking margarita and marking those papers so that you can have your grades for Monday morning to know whether or not you can come to class on Monday night. My final thing to you students is, one of the things that I don't understand, my colleagues and I, we have discussed this thoroughly. Thoroughly. Teachers not supposed to be able to play some games with students. If a teacher says a topic is coming, whether or not you like it, do it. Learn it enough so that you can reproduce it. When you finish reproducing it, you can leave it alone. This is all I'm going to say to you now. I'm not going to be entertaining no excuses from anybody. I'm not going to be entertaining no slackness from anybody. We're not going to learn the topic. So once I go through the questions with you, I'm going to give you yet another question to sit and do. And I'm going to give you another question to do for homework. And if you're not bad, come to class Monday without the homework question done. And see if you teach nothing. We're not have to learn something. Let's go. So you're all there by differentiating the function to get 6x squared plus 6x minus 12. For critical point, dy by dx is equal to 0, as I have told you. But one of the tricks that I'm using, and I have done this with you already in unit 1, because 6 is a factor of all the terms in the trinomial, I'm going to divide throughout the function by 6. Why, sir? It makes my factorization easier. It makes my factorization easier. So I'm going to divide throughout the function by 6. When I do that, I'm going to get x squared plus x plus minus 2. Yes, Astenil, I heard it got up to that point. But at this point in time, you still not giving me the answer I want. You're not giving me the critical points yet. So I know you got up to this point. Very good. Simon, where did you get to, Simon?
Sir, I got the negative 2, 13 and negative 1 and negative 14.
Okay, very good. Tristan, what did you get? And I know you hear me talking to you, Tristan. I decided I will not answer me. Please unmute and talk to me. What did you get? You know? Adrian, did you give it the question an attempt or are you still driving?
So I reach home, me never really there keep up with when you teach it, but me there saw watch what I go on with the group in and thing.
Mario, how you stay? Me not understand. You're not supposed to be in a class and me call up one and answer me. I don't understand what is happening here. Tristan, are you there? Mario, are you there?
Yeah, I'm here, sir. I'm just following along.
Yes, answer me when I talk to you, Bridget.
Sorry
Yeah,
about that, sir.
yeah, man. When I make me talking unnecessarily and when I talk a lot, I cough. I have a splitting headache now trying to teach you guys. Answer me when I call to in the morning, please. All right. So now that I have divided throughout by 6, let me caution you on something here. The only reason I was able to divide throughout the equation by 6 is because 6 is common to everything there. 6 is common to everything. Not all the time 6 is going to be common. Sometimes you're not going to have anything that is common, but just investigate your function and to see what it is like. All right. So now to factorize the trinomial above, we're going to multiply the coefficient of x squared by the constant term. Remembering that the coefficient of x squared is a number in front of x squared. The coefficient of x squared is a number in front of x squared, all right? So now I'm going to multiply this one by -2, and I'm going to get -2. I need two numbers. When multiplied together will give me -2, but when added will give me the middle number, which is +1. So the only two factors of 2 are 2 and 1. And because I want a +1, it means that the bigger number has to be a positive. So therefore, I'm going to have 2 and -1. 2 and -1. So what I'm doing, I'm splitting my middle term, which is my positive x, into 2x minus x, into 2x minus x. Then I'm going to be grouping. Once I group, I'm putting my x squared plus 2x in one bracket. I'm going to leave my middle sign out every single time. I'm leaving the middle sign out every single time. Now, so once a middle sign is out, as I told you before, it means that the last sign in the bracket above or in the term above is going to be flipped. So you see that this sign up here is a negative sign? Because I'm factoring out a negative sign, it's going to become positive. Why, sir? Because in each positive number, there are two negative numbers. In each positive number, there are two negative numbers. So in +1, I have a -1 and another -1. Because when I multiply those two numbers, I get back +1. All right? So, and besides, whatsoever sign that is in the first parentheses must be the same sign that is in the second parentheses. If not, you're not going to be able to factorize. You're not going to be able to factorize.
Sir, you said the sign that's in the first parentheses must be the same sign in the second parentheses.
Yes, sir. So you see that I have a plus sign right here and a plus sign on here. So when once you factor out this negative sign here, you factor out the negative sign, it means that this -2 here is going to become a +2. So that when I multiply this negative number by this +2, I get back that -2. See that?
Yes, sir.
Good job. And then I'm going to ask a question. What is common here that is common there? Your answer should be x. When I factor out a x, I'm going to have another x left. And when I factor out a x from 2x, I'm going to have just 2 left. I look at my second parentheses. I look at my second parentheses. And I ask the question, what is common between x and 2? And your answer should be 1. 1 is a factor of every single number. And the number itself is a factor of that number. So if we're talking about the number 5, I can take the 2 factors of 5 right off the bat. 1 and itself. 1 and 5. I'm looking at 2. I know 1 and 2 are factors of 2. All right? A rule of thumb. So therefore, what is now common between here and there will be x plus 2. So I'm able to factor out my x plus 2. I'm able to factor out my x plus 2. And in factoring out my x plus 2, when I take out this x plus 2, I'm going to have this x left. I put it back here. When I factor out this x plus 2, I'm going to have this positive 1, and which is what is right there. So technically, I'm going to have 2
Negative,
factors.
negative, sir.
Yeah, I just said that to see if you're awake. Very good. Thanks for being awake. So I'm going to have a negative 1. And I'm happy to know that you're following too. Negative 1. So now, what I'm going to have is x plus 2 times x minus 1 equals 0. So it's either 1 or both that is equal to 0. So let us check 1. So if x plus 2 is equal to 0, it implies right here, so that x is going to be equal to negative 2. And if x minus 1 is equal to 0, it implies that x is equal to 1. So now that's how we got our critical values to be 1 and negative 2. The critical values of x, not the critical points.
Sir,
don't
wait
reach
a minute. Yeah. X plus 2, or you get a negative 2 there?
If x plus 2 is equal to 0, what value do I add to 2 to get 0?
Okay, all right, continue.
All right. So those are known as my critical values. They are known as my critical values, right? So what we need to do now is to substitute each of those critical values into the original function so that we can get the corresponding y values. The critical x value with the critical y value together will give me my critical point. Do not believe that you complete the answer or the question by just evaluating the critical values. It's just the start of the question, right? So now you see me put x equal negative 2 into y. Y is my original function. See, recall y is equals to this. Now when I go ahead and substitute, you guys know the substitution. I'm going to get y equals 13. I refuse to do the substitution there. Y is going to be equals to 13. And when I substitute x equal 1 into the function, I'm going to get x coming out to be equals to negative 14. So those will be my critical points. My critical points will be negative 2, 13 and 1, negative 14. Congrats. Simon and Shabar. Congratulations for getting those two. Astinil, you need to be able to complete.
Yes, I saw where I made the mistake.
Okay, I'm happy. The rest of you need to participate in class. All right. And then the nature of the critical points. Now, the method that I used here is not the method that I want you to use just now. It's a longer method. Don't have the time to go through it. I will do it one of these nights I'm going to skip this method, and then I'm going to ask you, I'm going to look at the differential of it, because now we need to ouch, that's one that was burning me. Now we need to classify the nature of the critical points. The notes that I sent to you just now says that when you're classifying the nature of the critical points, I need to find the second derivative. I need to find the second derivative. When I differentiate the function once more, I'm going to get 12x plus 6. Tell me if you agree with me.
Great, sir.
All right, good job. And then, similar to when we're finding the first derivative, to find the, sorry, I was jumping to the point of inflection. So I have now 12x plus 6. I'm going to look at my critical points. And for my critical points, I'm going to make a substitution. If the value is positive, I have a minimum. If the value is negative, I have a maximum. If the value is equal to 0, I have a saddle point. So let's go. 12x plus 6 is my number that I'm looking at. When x is negative 2, 12 times negative 2 is negative 24. Negative 24 plus 6 is negative 18. That's a negative value, so therefore it is a
Maximum.
maximum. So the values are maximum at 2,13, negative 2,13. So what I have here, I'm not teaching you this method, but the method also works. So when x equals negative 2, let us jump to the last part of it. It says a local maximum. All right. Now, similarly, we have the critical point 1, negative 14. When we substitute 1 into the function, 12 times 1 is 12, and 12 plus 6 is 18. That's positive. Once it is positive, we have a
Minimum.
a minimum. So at 1, negative 14, we're going to have a minimum value. See here? You don't need to look at that method. We're using the short of the two methods tonight. We're going to have a minimum value. All right. Now, so we know the local maximum. We know that we have a local maximum, we have a local minimum. We now need to find the point of inflection. And again, we're going to be using the second derivative. And we're setting the second derivative equals to 0. We're setting the second derivative equals to 0. So we have 12x minus 6. Or 12x plus 6. So we're going to let 12x plus 6 equals 0. So therefore, we're going to subtract 6 from both sides. So we're going to have 12x is equal to negative 6. And then we're going to divide both sides by 12. So we're going to get x is equal to negative 6 over 12. X therefore is going to be equal to a half, negative a half. X is going to be equal to negative a half. What we're going to be doing is to substitute this x equals negative a half into our original function. Listen up. There are times marking papers and see students make the mistake of substituting this into the differential. If I go wrong, we always go back to the original function. So please ensure that you are making the substitution to the original function. So anywhere in the original function we see x, we're going to substitute negative 1/2. I'm not here to teach a substitution, but when I did my substitution, I got y to be equal to negative 1/2. Did anybody get that? Is that a yes or a no, you know?
I got minus a half, but I don't get the other half.
All right, so that's something that you need to try to see where it is that you would have gone wrong. It's supposed to be negative 1/2. And then no, the final thing, because I'm going to give you one more to do. I'm going to send you the solution to this, and I'm going to give you another function to do, because as I said before, I'm not joking with you guys. And I'm going to give you about 20 minutes, 25 minutes to do the question, and then we're going to come back with the solution. All right? Now, when I'm making a sketch of the graph is not, we're not plotting it, so it's not going to be accurate. It's just a sketch. However, the sketch is supposed to be as close to accurate as possible, whereby all the points you have calculated in the question must be represented on the graph. So the y-intercept must be shown, the critical points must be shown, the point of inflection must be shown, the maximum value must be shown, the minimum value must be shown, right? And this is how you end up with about 6 marks on the graph. So you have to show those values on your graph. So my maximum turns like an N. So think of N and think of the word negative. Negative begins with an N. So when you see your graph turns on like looking like an N, it is a negative graph. When the graph turns upwards, it's a positive graph. So this is where my minimum is. My minimum is going to be a U. This is minimum. It looks like a U, so my minimum is down here. My maximum is going to look like an N, so my maximum is up top. This has a maximum value, this here has a minimum value. And my point of inflection is going to be somewhere right here. Midpoint between the maximum and the minimum. And that's what your graph looks like. I'm going to stop share. I'm going to send you another document with the solution to this question that we just did. I'm going to give you time. I'm not going to give you, do you want to give you the method that I don't want to teach you just yet, or leave it out? The choice is yours.
And the question?
And I'm saying the method, you remember I said that there are 2 methods to classify the nature of the stationary points?
Mm-hmm.
Right. So I'm saying I didn't do the method that I have on the document here. Within the document here, I didn't teach you that method. So I'm saying, do you want me to send that method to you nonetheless, or just leave it out?
So that's what you have on the document, and I want it on the.
You want it?
Yes, sir.
Okay, no problem. Because at some point in time, I'll go through it with you. It works. It's just a longer method, and because time is against us, I don't want to spend a lot of time doing this when I could use an easier method to get the job done nonetheless. All right, so I am updating my file. I'm sending you I'm resending the document that I sent you earlier, the first part of it. I'm adding the solutions that I just went through with you just now. And I'm also giving you I'm also giving you an additional question to do for me. So here what is going to happen. We still have about 45 minutes for class. So here what is going to happen. You're going to take some time, especially if you didn't get all the components correctly. Let me know if you received the WhatsApp document, please. Let us agree, this is what is going to happen. You're going to go through the document, the solutions once more, and then especially the areas that you didn't get well, correct? And then you're going to attempt the 3rd question for me. Now, before we end tonight, I must go through that 3rd question with you. Because after tonight, this topic is finished. I have 2 weeks to complete the rest of the syllabus. I have 2 weeks to complete the rest of the syllabus. All right? So go through it. I am here. If you have any questions, you can unmute and talk to me. I do not want, and to each his own. Honesty is the best policy. If you want to go up on TikTok or go sleep, your funeral. But I would encourage you to go through the document, to attempt the question. You may want to go ahead and just straight attempt the question while looking at the document. to work with it, I have no problem. However, you're going to do it at about 8:40. I'm going to stop you. All right. Happy working.
Sir, sir.
Yes, yes, Papa.
All right. The document you recently sent, it will be a work plan. I go through it.
Yeah, go through it. The solution that I just did a while ago is embedded in that document. And at the end of the document is another question that I want you to work for me on in class.
Wait, sir. Me not see that. This is 5A. Oh, 5A and B. Let's say example 4.
Yes, sir.
All right.
Somebody was trying to come in a while ago. Okay, all right. So are you finished with the how far are you with the last question I just gave?
Finish looking over, sir.
Good job. Good job. I love the sound of that. Um, I want you to agree with me that that the questions are pretty similar to the one that we did before. True or false?
True.
Yeah, man. The only thing that changed in that question is what?
The consult at the end.
And the function. Very good. Right. The function. The function. Yeah. Everything else remains the same. All right. Um, Simon, how far are you?
Sir, still working.
Yeah. How far are you?
I'm at the y-intercept.
Okay. All right. I'll give you a few more minutes and then I'll go through the stuff with you. 5 more minutes. How we stay now? Now 8:40. Are we finished or you need another 5 minutes?
Yes, sir. 5 more minutes would be more than
Okay, 5 minutes. And at the end of those 5 minutes, that's it.
Alright, so you probably have to go move on before me, because I'm still there, catch up back with the first one.
All right, that's it. Let's go. Let's go, let's go, let's go, let's go, let's go. What do you got for the critical points for that one? For part one. What's the critical points?
Sir, I got for the first one, sorry, 20 and -7.
You can't give me the critical points like that. Mario has 20 and -7.
All right, sir. For the first one, sir, we're oh, yes, yes. Sir, I'm not sure of it.
No, come on. Based on what you said to me, you have the answer in your book. How did you get the 20? What did you do to get the 20? What did you substitute to get the 20?
Uh, uh, for the first answer, I substitute x for -2.
Good. So therefore, the critical point is going to be what?
The critical point is going to be yes, critical point is
You just told me a while ago. Tell me, come on.
20, sir.
You can't just say 20. It has to be something, comma 20. What is it? What did you substitute to get the 20?
Why, sir?
Hey boy, what did you substitute a while ago?
X, sir, sorry.
What is the value of x? Mario, work with me. Work with me now, Mario.
Yes,
You
sir.
got, you got 20, right?
Yes, sir.
20 is a correct answer. But what did you substitute in order to get the 20? What did
I
you what is substituted into the function to get the 20?
So for the value of x, sir, I substitute it as -2.
-2?
Yes, sir.
Okay. So therefore, your coordinate is going to be what?
Um,
-2 and 20.
You heard Mario?
yes, sir.
Okay. Now correct the second one and tell me the thing now.
All right, sir. So for the second one, I substituted the value of x to 1.
Mm-hmm.
So the coordinate I have, sir, is 1 and -7.
Very good. 1, -7. Very good. I'm not I'm not trying to be difficult. I just want you to get it. Right? So you'd have gotten all of that. So therefore the stationary points are -20, -2, 20, and 1, -7. Yeah, Tristan is not in class, but is Simon,
Sir.
where you stay?
Yes, sir, I got it.
Shamari, where you stay?
I got the critical points, sir.
All right, good job. Adrian, where you stay?
Alright, sir. Me there, me there way behind. Me there example 2 I try jot it down and understand.
Right. Okay. So
On the paper I sent before. The examples were sent before.
mhm. All right. So for the nature, classifying the nature of the critical points, we need to investigate now the change in our differential. So remember, the first differential was 6x squared plus 6x minus 12. Yeah. And I'm going to substitute x equals -2 in a function. Boom. When I substitute x equals -2, I'm going to get this method that I use in here is the method that I don't want to teach you just yet. So I'm doing this one out of my headspace now. And I substitute this one here, -2, -2. Oh, I have the alternative one down here. Good. So this is the one I'm looking at. -2 times 12 is going to be -24 plus 6, -18. Negative is a maximum. So once it's negative, it's a maximum. So once it's negative, it's a maximum. And then we're going to try the one with the 1 now. 1 and 7. And you substitute 1 in there. 6 plus 6 is 12. 12. I get positive 18, so it's going to be minimum. So did you get maximum for your 2, -2, 20, and 1, 7, -7, you got a minimum? Yes, no?
Yes, sir, I got that.
Okay.
Yes, sir.
Good job. Astonil, I need to talk to you off air immediately following class here. Oh, she said that she's busy.
Say that again, sir.
Oh,
Back and forth.
you're back. Okay. I said I need to talk to you immediately after class.
Okay,
Just give me a quick WhatsApp call.
sure.
Adrian, I need to talk to you as well, but I'm going to talk to Aston first. So give me about 5 minutes after class, Adrian, and then they call me here.
Yes, sir. 5 minutes after 9.
Yeah. All right. And then now, the y-intercept, you put x equals 0. Anybody got 0, 0?
Sir.
Yes, sir.
Nice. Aston nearly got 0, 0.
Yes, sir.
Point of inflection, what you got? Anybody, somebody?
-1/2 and 13/2.
Good job. Shamari, where you stay?
Just finish it, sir, and I got it.
Good job, son. Simon,
Yeah, I got it, sir.
good job. And then the sketch now, my sketch looks like that. Tell me if your sketch looks anything similar to that one. Yes, no, maybe so.
I had stepped away from the computer, sir, so I never reach up to a graph part.
All right, no problem. Can do that for homework. All right. Very nice. I am going to send you that solution. And I'm going to also give you another bit of question to do for me. If you feel up to it, you can. Oh God, no man. Every cup, my head hurts. If you feel up to it, you can sit up and do the question tonight. But please, students, you have to put this to long-term memory. The topic is finished. I don't have another day to go through the topic again. Yes, I can give you a question or two to do for me, but the topic finished. All right. So I just sent you something via WhatsApp. Go through. As soon as the recording becomes available, I send it off to you. Complete my Educosoft pieces, please. There are some of you who started out and don't know nothing more. Some of you don't start yet. Some of you are moving nicely. Go through your Educosoft pieces. Remember, students, you have 2 weeks to cover your Educosoft. As soon as I finish marking the papers, I'm going to just submit the grades. I don't have time for wait and say, sorry, give me 2 more days. Nope. Don't have the time for that. Pick up on yourself. Have a good one, yeah?
You as well, sir.
Oh, thanks. Arsenal, give me a call, please. Simon, you're the host. Can you end the meeting for all for me, please, Simon?
Yes, sir.
Thank you.